Hello Internet and fellow network engineers. My name is Maxim. I share network tips and tricks with you on my channel. This video is the second one in the series of 3 dedicated to securing IoT or Internet of Things. This video will contain the practical exercise which I will show you in my lab. The devices which I will show in my demo is the Juniper SRX series firewall, the model SRX 300. I will also be using Juniper Mist AI wireless solution, specifically Wi-Fi 6 AP 12. And also we'll be using Raspberry Pi 0W. So despite there is a more modern version too, which I also use in my production network, we'll be using the first version, and it is plenty of performance for what we need. I have already installed Pi-hole on this device, and it is ready to go for our demo. If you are interested in how I installed the Pi-hole to this device, there will be video number 3, which is called the bonus content, and there I will show you step-by-step process how you can provision your own instance of Pi-hole to one of these. So, if you are ready, let's go. So, let's start. And to avoid accidental death from boredom, we'll do it in a game format. Let's play some game. So in this case, let's look at the screen, and this is our beginning of our game. This is the example of the unprotected, insecure network, which we during our game will be protecting. Live with you, I will do all the changes for my proposed solution and show you that it's not that difficult and not that long and doesn't require a lot of maintenance, right? So let's jump to it. First step in our journey is segmentation, and in this case we'll be segmenting our management network in this dedicated security zone. So why is it important? Because this is how Mist AP is configured. So in your Mist AP you have an IP address which the access point is using to connect to the cloud and get all the management and telemetry. And also you add the additional VLANs going in a tagged format toward the AP for your SSIDs. In the beginning, it was in the single security zone. We would like to isolate our management from our trust as a first step. I will start from showing you current configuration. I will just scroll through. It is basic, just 2 zones, different interfaces are assigned. We have 2 IRBs, we have 2 DHCP pools, and we even have some IoT devices today to use. We'll be using a light bulb, we'll be using a light switch, and air purifier. So this will be our examples in this case. So we checked through our configuration. Let's have a look at our DHCP binding. Right. So in my case, I pre-configured my devices, my IoT devices, with a static DHCP reservation, and we'll go over it a little later when we'll talk about Pi-hole, why it is useful. But it also helps us to identify them easily. So these are our 3 IoT devices. Plus we have something from 0 subnet. This is our management subnet. This is the AP itself, how it goes and communicates to the cloud. And then we also have our laptop. So either this one or this one is our laptop, which I'm currently doing the work on. And another one is something simulating a wired IoT client. This is just another network device representing the wired portion of the IoT segment. Yep, I would say let's start and let's go to our target. So we are going to create a security zone. So our security zone will be called MGMT. So we need to enable DHCP because our AP relies on the DHCP. And we are moving our IRB10 interface to it. And now we need to delete IRB10 from our trust zone. Okay, let's have a look what we have. We have trust zone, we have untrust zone, we have management. So now we dedicated it, put it in the dedicated security zone, but it immediately requires us to create net source net rule for it. So in this case, we'll have a rule set called mgmt to untrust. It will be coming from zone mgmt. To zone untrust. Rule mgmt to untrust rule 1. Match source address 192.168.0.0/24. Then source net interface. So now what we need to do, we need to remove that existing rule from the trust to untrust. And it is called trust to untrust rule 2. Okay, so this is what we get. So now we have dedicated management to untrust rule and the dedicated trust to untrust rule. Okay, so this is covering our net. Next step is security policy. Okay, so we'll create a rule. So from zone mgmt to zone untrust policy permit mgmt to untrust match source address mgmt subnet destination address any IPv4 application any. So we'll focus on filtering later. So currently our idea is to segment them. So then permit, and also we need to clear our first row from zone trust to zone untrust match source address mgmt subnet. Let's have a look what we get. Okay, I like it. So we are done with this step. Perfect. Now we are going to do commit. Okay, so and now we are looking at our next target. Next target is 20% of the progress. So in this case, you now see that we have a dedicated IoT VLAN. We'll have a dedicated security zone, and we'll also place our wired IoT device to that IoT VLAN. So let's handle it. So we'll start with creating additional VLAN. We'll call it IoT, and it will be VLAN 30 and IRB30 layer 3 interface. Let's have a look. It looks good. So next step, we'll configure our IRB interface. Okay, and we'll put a description on it. Have a look. Yeah, looks good. So next step is security zone. Okay, set security zones. Security zone IoT. Post and bound traffic DHCP. Okay, next we'll put our interface. Yeah, so now we have security zone configured. So next step will be, let's cover our net. Okay, IoT to trust, rule 1, match source address 20/24, then source net interface. Let's have a look. Yeah, looks good to me. So next step, we'll need to create a security policy, but before we need to create a security policy, we need to create a security address book. This is how it looks right now. So again, I prefer to use global. It just makes it simpler. I create a new address book. Entry, perfect. And now I go to the policies and I'll create a new policy. From IoT to untrust, policy. Again, filtering will cover in the dedicated section. Currently, we just need to make it functional. Destination address, any IPv4, application any. And then permit. Okay, now we have our security policy set. So next step is we need to create a DHCP pool. To do it, first we need to go to System Services and we'll need to enable interface. I have a local group already here present, so I'll just need to add one more interface here. Looks good. So now I go to Access Address Assignments section. This is where all my pools are currently present, so I can do display set. Right, so I'm creating additional pool, and I call it IoT pool, family iNet, network 192.168.2.0.24. Okay, and then I'm going to do range. And I call it IoT range. Low will be 192.168.220. High 192.168.200. Okay, after range we are doing DHCP attributes name server. So currently we are pointing it to the DNS servers located in the internet. And then I'm doing router 192.168.2.1. Okay, that's good. Let's do, and I will do additional step again, which will be helpful later in this demo. So I'm going to create static reservation. Pool IoT pool, family iNet host, and I'll basically be doing the same thing as here. But there will be a difference in subnet, so this one will be 2 and this one will be 2.6 and the light switch will be 2.7. Okay. Let's have a look. It looks good to me. Yeah. So this part is ready. Next we are going to our current interface. As you can see, we have interface which is wired IoT device, and currently it is in VLAN trust. So we would like to change that. So we are going to do, oops, this, and then we need to delete, and we really need to delete trust. So displace it. Yeah, so now it is in our proper VLAN. Okay, and that's it. So let's have a look at what we have done. So we have DHCP configuration, we have address set, source net, policies, zones, a wired interface, IRB, DHCP pool, and VLAN. So in this case we are going to do the commit. Commit is successful. So next step will be, remember our wired interface, a wired device. It still holds that address, right? So what we are going to do, we are going to do next thing. So we're doing show Ethernet switching table, and we are looking for the one which is connected to GE003. TCP server binding, and oh yeah, now it basically switched the VLAN, but remember that we need to bounce the port so the client will be able to get and request a new address. So this is what we are going to do. We are going to, and again, to double check ourselves, we can do run show VLANs, and we can see our IoT device, and star in the end means it is in up state. So we are going to disable it, and then we'll enable it back. Now we are doing rollback 1, and we are enabling this interface back. Commit is successful, so now we can do show interface as source. Interface is in up state, show DHCP server binding. And we can see it now. So this is our first device, and we can double check, always double check Ethernet switching table by looking at that MAC 00C4 00C4 IoT interface 4. So this is by shutting and shutting interface, you force the device to obtain address again. So again, we reached our 20%. So let's have a look what is going to be in the next step. Next step is 30%, and by reaching that goal we'll get our first gold star. So let's have a look what we'll be doing here. By looking at this picture, you may notice that now we have a dedicated IoT SSID. So in this step we'll first touch our Mist interface and touch our Mist AP. But first we'll need to add our IoT VLAN to a trunk toward our AP. Right? Let's do it. Okay, so this is trunk to our AP, GE001. So how the Mist AP configuration look like? You set it as a trunk. You provide management VLAN, which AP will get address in, and then you provide other VLANs as necessary for your SSIDs. And then you make your management VLAN native VLAN ID by basically sending this traffic untagged. So in our case, what we need to do, we need to add our IoT VLAN to a members list. Okay? And we'll be all ready to go on the wired side, and then we'll jump to the Mist side. This is our time to look at our Mist cloud interface. This is the place where we manage our wireless network, our wireless AP. This tab is called Wi-Fi clients, and we can see currently 4 connected clients at the moment. The number 1 is the smart switch, then air purifier, then laptop, which I'm currently recording it from, and then the smart bulb. On the right side, we can see that currently they are all connected to the Trust SSID. So next step is I'm going to organization and WLAN templates, and this is where I have my lab WLAN template, and currently it has just the Trust SSID. So I'm going to add an SSID. I will call it IoT, and I will be using the WPA2 PSK, and I can reveal it. It's IoT key 123, and then I'm adding the VLAN tag, which is 30, and I hit create. So now again, as soon as I push create, the configuration change is being pushed by the cloud to the AP, and shortly it will start broadcasting the new SSID. So again, in this case, we finalized our segmentation step and we get that gold star. We are targeting 40%, and this is our second level, which is isolation. So in this specific next step, this is what we are going to do. We are going to create individual multiple pre-shared keys for our IoT devices, and then we'll be reconnecting our IoT devices to our IoT network using those new dedicated keys. Another thing what is worth mentioning here, in this case I usually recommend to also change your key for the trust network, because again you may be using it in the past with different IoT devices and expose it to the cloud, so you would like to get rid of it and keep it private and be changed to a proper secure key. And then we'll do some kind of testing functionality of the IoT devices. So let's return to our Mist interface. And this is what we are going to do. We are going to go inside our IoT SSID, and we'll be changing the configuration for the security. We'll be doing something called multiple passphrases with the local storage. And we are going to click Save. And then the next step is to configure those keys. To do that, we are going to Site, and then we are going to WLANs. Currently, what we are seeing, based on our change, the Mist AP is applying the change and restarting the radio, and we briefly lost our Wi-Fi connection to it, but it is already restored because we are connected to the same AP currently. Okay, so now here we have our two SSIDs listed. So as soon as we go to our IoT SSID, we can configure our individual keys. So here I pre-configured the keys already before, but for us, again, for this demo, I'm going to delete those keys and we'll be configuring those with you again. Okay, so it is multiple, again, with here we can add the key for certain site, and in our case it will be vendor 1 key. This is the name. And then this is the VLAN ID, which we will be using it. This is our IoT VLAN. And the passphrase will be vendor 1 key. So this is how it will look like. And it is multiple users. So there are multiple devices will be using the same key. Okay, create. And then we'll create second. Vendor 2 key, 30. Vendor 2 key lowercase, yeah, like that, create, and then we'll create vendor 3 key, 30, vendor 3 key. Okay, perfect. So we created multiple pre-shared keys for our IoT devices. Right, again, I already showed you that you can, again, remove a key or you can create a new key. So all in this interface. So next step, I'm going to reconnect my IoT devices to this new network. And we'll see, so you will basically see in the real time, so I will speed up the process, but you will see how it changes. Pay attention to this right side of the screen. So let's get to it. So I'm back. I reconnected my 3 test IoT devices to this new SSID, and you can see result for yourself. So you can notice that now 3 devices out of 4 are connected to the IoT SSID using 3 different keys. And these are not the key text itself, not the secret portion of it. This is just the name of the key. You can name it whatever you like. But this gives you the great visibility, so how your device is connected and what keys they're using, right? Again, there is a nice functionality to change the name, so you can change your device's names to give them more personal to you. So this is awesome. So next step is I tested functionality. So the devices, again, they are connected to the network, they are working. By doing that, so we verify also our DHCP, security policies, net, everything we've done before, right? So this concludes the 40%. So we reached our 40% goal in the isolation level 2. We are going to look in our next step. Our next goal is 50%, right? So let's have a look at our 50% and our chance to get the second gold star. So what is changed here? Here we'll start working with isolation of the IoT SSID. So we'll enable isolation. I'll show you how to do it in the web interface. And we'll also enable optional ARP and BAM traffic filtering, so which can increase safety and performance of our wireless network. Yep, we are back to the Mist UI. Let's look into the configuration. So to do that, we'll need to again go to Organization WLAN Templates. This configuration is done on the SSID itself. So we'll need to go to our template and we need to jump to IoT template. And then here we will go down, we'll scroll down and we'll find this section. It's called isolation over here, right? And there again, as I mentioned, if it is disabled, your devices can communicate to any other wireless or wired device in your network. So we don't want that. If we go and do same AP, it will be just in the AP range. So wireless device connected to one AP cannot communicate to other wireless devices connected to the same AP, but they can communicate to your wired devices, they can communicate to other wireless devices connected to a different AP, because you may have your wireless network containing multiple APs. In our case, again, the most appropriate solution for our use case is the same subnet. So it will allow wireless clients to go only to the gateway, not to other wired or wireless, any IPs from the same subnet. And the next thing is filtering wireless. So we are enabling ARP. So we are filtering ARP to go toward our wireless network. Our AP will be acting as a proxy ARP device. And also it is recommended to enable broadcast and multicast, same idea. So we don't want to for that broadcast traffic unnecessarily go to our wireless networks. Again, ARP is not considered. ARP will be like proxied by the AP itself. And we also can allow MDNS if you plan to use it. But this is like something you can you can use. And this is our isolation method we are going to use. So we are hitting save. Again, same idea, we hit save, the configuration is pushed to AP, and in a few seconds we'll be all set. Again, it concludes our second level. And now we got the gold stars. Right? So the next step is, let's look at our 65% goal and what we'll be doing here. So in this case now it's we start touching our DMZ portion. So we need to prepare the DMZ segment and for our Pi-hole server. Let's start. Now we again back to our Juniper SRX. We need to prepare our DMZ. So in order to do that, again, it all starts with the VLAN. We could do a P2P layer 3 to the Pi-hole, but again, my idea of the solution is to give you flexible solution, because you may again add secondary Raspberry Pi with your secondary Pi-hole image or other DMZ devices, network devices, right? So it is more flexible to use a VLAN and IRB for DMZ specifically. Yeah, so we'll look into our current configuration. We'll create a VLAN called DMZ, and it will be VLAN ID 40 and layer 3 interface IRD 40. Okay, it looks good. So next we'll go and create IRB. Edit interfaces, IRB. Okay, set unit 40. Okay, and I prefer to add a description, DMZ, to it. Okay, it looks good. So next step, we are going to configure our interface. So we'll go to interface, our physical interface. Yeah, so we can see our GE002 is not configured yet, so we are going to configure it. Yeah, we'll give it a description. We'll put it in the DMZ VLAN and enable it in the access mode. Okay, so now we have our layer 2 interface. So next step is to create a security zone. We'll call it DMZ. We'll allow DHCP to come. And we'll put interface IRB 40. Perfect. Yeah, our security zone is all set. So next step is source net. Okay, we'll create a new rule set. We'll call it DMZ to untrust from zone DMZ to zone untrust, rule DMZ to untrust rule 1, match source address, then source net interface. Again, I usually don't make it overcomplicated. I don't do any filtering in the source net, so we'll do it in the security zones, security policies later. So it looks good. So next step, we'll need to work on our security policies, and again, before doing that, we need to create address book entry, because you can mention only address book entries or and address sets in the security policies. So we'll do global address Pi-hole DMZ 192.168.32.32. So this is just for a certain host, and then we are going to go to security policies. Okay. And in this case, we need to create, first, we'll need to create a security policy from zone trust to zone DMZ, policy trust to DMZ, match source address, trust subnet, destination address, Pi-hole DMZ, application. So in our case, what we need a Junos ping, we need SSH, we need HTTP, and that's it. So now we need to do then permit. Okay, so this is done. So now we need to do second thing. So we need to do set from zone DMZ to zone untrust. And we'll do policy permit DMZ to untrust, match source address Pi-hole, destination address any IPv4, application any. Again, filtering is we'll do later. Then permit. Okay, so next step is we need to create one more thing. We'll need to create a policy from zone IoT to zone DMZ. Policy permit DNS IoT to DMZ. Match source address IoT subnet, destination address Pi-hole, application Juniper DNS UDP and TCP. Then permit. Okay, so we covered all our policies, so let's verify that. Yeah. So we made trust to DMZ, so this is how we'll manage from this PC, we'll manage the Pi-hole. Then from DMZ to untrust, this is how Pi-hole will interact to the internet. And IoT to DMZ, this is how IoT will go with the DNS requests toward our Pi-hole. So now it's time to commit. The commit is successful. So now we'll do a quick verification. So we are going to ping our Pi-hole and verify if we can reach it. Yep. So we can reach it. Great. So this concludes our 65% step and our first step in the level 3 filtering. So let's have a look at our next step. So our next goal is 80%, and so let's have a look at what we'll be doing in this step. So at this step we'll start configuring our Pi-hole. So I will show you the interface, and so we'll start our journey there. But before doing that, let's again focus on the CLI of the Juniper SRX, and this is what we'll need to do prior to going there. Yep, so we are back to SRX. So we are going to connect to our Pi-hole and do one thing in the SSH. Again, in my case, I can create a connection from the laptop because I allowed SSH, or I can just simply SSH directly from the Pi-hole. I'm sorry, from the SRX to Pi-hole. Okay. Perfect. So we are inside the Pi-hole, and here what we'll need to do, we'll need to do the next thing. So we'll need to do, okay. So what we are going to do, we are going to create the entries for our IoT devices. Remember I told in the beginning that we are doing DHCP reservation for the addresses for our IoT devices. Because they have fixed addresses received from the DHCP server, now we can create entries on the Pi-hole. In this case, we'll be able later to identify those devices and show the nice proper name for them. So it can make your life a lot easier. So to do that, so I'm going to just create pairs IP to basically the device name in this etc hosts file. Okay. Yeah, so just 3 entries for our devices, and then I need to save. Okay, and then I need to go to exit. So now let's connect to our Pi and have a look at that interface. Login. Okay, so this is the main interface of the Pi-hole. So we'll start by doing next thing. So again, remember we don't send any DNS traffic to it yet, right? Because the IoT DHCP is still providing internet DNS addresses to the IoT devices. But we need to do some kind of pre-configuration on this device. So we are going to go to settings, and then we go into DNS, and then there is interface settings. This is what we need to start from. By default, it allows only local requests, so it won't answer to any requests from the outside of its subnet. So we would like to make it responding on our wired interface to every device. Again, it's potentially dangerous, but we have a firewall and proper protection in place and isolation from our network. So we are enabling that, and then we do save. So next step is we are going to go to domains, and we'll be doing, by default, it will be basically allowing requests to go out and doing your add list, depending on how you set it up. See, by the way, video 3, a bonus content, where we'll set the Pi-hole from scratch. So to show you the whole process, just how the Pi-hole can reach this specific moment. There is like a dedicated list, dynamic list, which blocks advertisements and certain malicious links, which again you can customize here, different lists as you like. We don't focus on that. We would like to create a blacklist first, which will have all the addresses. So I'll show you how to do it. There is an option to add a domain here, or a regex, right? We will go to the regular expression, and we'll do .star, which will cover all the entries, and then we'll do add to blacklist, right? Then we can do comment. We can do block all by default. So this is how we basically enable, and again you can enable disable, but this is drops all the requests coming to it. Pure and simple, and this is exactly what we need. So now what we need to do, we are going to jump back to our SRX, and now we are changing our DNS configuration in the DHCP to point our IoT devices to this new Pi-hole. And we are going to change our DHCP. So let's do that. Edit access address assignment. Okay, we are going to IoT pool, and we technically can do show display set. It will be easier. We can do delete address assignment pool, this one, IoT, correct? No, from here. Okay. Perfect. And now we are pointing it to our Pi-hole. Plain and simple. Okay, as a precaution, we are going to clear DHCP server binding all, just to get rid of all the current bindings. And now we are going to jump back to the our Mist wireless interface, and we are going to restart our AP to make sure that all the IoT devices are reconnected and getting new DNS address. Wireless configuration, we are going to our access point. We are going inside the access point. We are going to do utilities and then reboot AP. Okay, so AP reboot is initiated. So soon laptop will disconnect from the wireless because the AP is rebooting. And as soon as it is back up, I'll see the icon in the bottom right, and we'll start looking at the Pi-hole interface. Yep, our Wi-Fi is reconnected back. So we are going to clients. So we have our clients connected. So now we're going to Pi-hole, and we can go to the query log. Okay, so we have something, right? So we updated, we have total queries, we have 3 active clients, which is very important for us, right? Because it means all our wireless devices got the new lease with a new DNS address and now pointing to our Pi-hole. Okay, so again, for our current to reach our current goal in this specific step, we need to go to the query log, and this is, you can see, a column called client, right? And you can see it has a proper nice name to it. This is because we added those entries in the etc hosts file. Okay, so in this interface we currently see that everything is being blocked based by blacklist, because this is our intention. We would like to block everything at this moment. You can click on a certain device and it will group your entries for that specific client, right? You can click again and return back. You can go to the next page. You can click on, let's say, air purifier, etc. Right? So this is okay. For now, we see 3 active clients, and this is enough. So it concludes the 80% goal. And now let's go and look at the next step, which is the next target is 90%. So what we'll be doing at 90%, we'll be executing our zero trust approach on the SRX. So I'm going to share SRX and we'll continue. We are on SRX and we'll start with we'll go to configuration mode. We'll do show security, display set. And the first step which we need to verify is our default policy, and this is something we need to configure. We'll do deny all. So this is what happens if the traffic doesn't match our policies. So we would like to explicitly say that we would like to drop anything which is not in profile with our configuration. Right, so this is step 1. So next step, we'll need to verify our security zone configuration. So show security zones to verify our host environment traffic. Yep, let's have a look. Untrust, nothing. Trust, DHCP. Again, probably you may need here DHCP if you have dynamic address to ISP. In this scenario, I don't. For the trust, DHCP ping SSH traceroute. For management, DHCP, IoT DHCP, DMZ DHCP, right? Again, in our case, we didn't configure the DMZ pool, but you can configure similarly to how we did it before, because in our case, Pi-hole has a static address. It's not that important, but it fits in our zero trust profile. So next step, let's look at the policy. Okay, and we'll start with the management to untrust. Let's have a look. Management to untrust. Currently it is any, but we'll be changing that. So we'll do management to untrust, policy, show, delete, match, application, any. And we'll be changing it to Junos ping, Junos NTP, and Junos HTTPS. And also what we need DNS UDP. So again, everything else is using the internet DNS server for simplicity for this case. So let's have a look at the difference. So now we explicitly mentioned the services which our AP needs to go to communicating to the cloud. Next, we'll cover IoT to DMZ. Okay. In this case, it's just IoT can go using DNS. So this is correct and matching our intention. So next step is IoT to untrust. Yeah. In this case, again, we don't limit it, and I'll show you a little bit later why. But I need to add one more policy over here. So we'll need to do deny DNS policy, match source address, IoT subnet, destination address, any IPv4, application Junos DNS UDP or TCP. then deny, and insert term policy deny before policy permit. Yep, and you can see, so we need to deny clear text DNS to make sure that our IoT devices are not going to the internet for the DNS, and then we allow everything else. So, because again, we rely more on the DNS filtering than on the IP filtering for our IoT. So now we go up. Next step is DMZ to untrust. Okay, so currently it's any, but we'll change the same idea, so we'll remove any. And we'll replace it with the specific services Pi-hole needs. We'll enable ping, we'll enable HTTPS, we'll enable NTP, DNS, UDP, DNS, TCP, and I guess that's it. So let's have a look. Yep. So that's good. So next step is up, and we'll check from zone trust to zone DMZ, and I guess it is correct. Yep, it's just management protocols. That's good. And finally, from trust to untrust. Again, it's a personal preference how you would like to limit those. I just keep it permit for this lab demo. So we covered our policies. So let's do show compare, and let's do the commit. Yep, so this is done. It concludes our 90% block, and let's look at our final block to complete our game. So we are going to work on our Pi-hole and set the proper filtering, DNS filtering in the Pi-hole. So that's the most exciting part. We are just one step before our goal. So we are currently looking at the Pi-hole, and we are in the dashboard. So we see the total queries came is 53, and all of them are blocked, right? So what we can do, we can scroll down in our interface and we can see top blocked domains. So this is one of the ways how you can start approaching our goal. These are the blocked domains. You can just start from the top, or this is how I do it. So let me show my example. So I'm going to query log, and then I click on my first device, let's say on light bulb, and I will see all the domains it has requested, right? So again, in my case, it's just a single one. So you can see again, just this is exactly what I was talking about, difficulty how we can manage it with a regular firewall. I will like to ignore this first portion, but I would like to set the wildcard for the IoT US West to Amazon AWS.com. So what I'm doing, I'm going to domain, I'm going to regular expression, and this is what I'm doing. So I'm doing IoT US West -2 Amazon AWS.com, and the description is light bulb. So this is needed by light bulb. So let me double check, US West 2 Amazon AWS.com. So, and I'm adding it to whitelist. Okay, so this is a whitelist. So now I allow it, right? Okay, I go to query back, and then I click on my air purifier. So what my air purifier needs. So I go to next page. Yep, it just requests the same thing. So something unknown at .vsync.com. And I know that vsync is the app which is I use to manage my air purifier, and I trust this domain. So I will do again wildcard anything .vsync.com. So I'm going to domains, regular expression, and I'm going to do vsync.com, and description is air purifier. Okay, add to whitelist. Perfect. go back to query log, and it will be basically back and forth. So next step is I'm going to do light switch. So I haven't touched light switch yet. Again, I know TP-Link, right? So this is basically the vendor of my switch, and I see TP-Link-cloud.com, TP-Link-cloud.com. So what else? Okay, timemist.gov, poolntp.org. So I trust all of it. So I will create the entries for it. So let's go to the domains, and we'll be adding regular expressions. So let's start with TP-Link-cloud.com, light switch, whitelist. Okay. Query. So you can see some of them are already being answered. So I'm going to jump into the light switch. Okay. And for these two, what I can do, I can just directly add it to the whitelist right from here. Okay. Whitelist and poolntp.org whitelist. Okay. So I'm going to domains, and I'm scrolling down, and these are the two domains, not wildcard, but just domains, and I can change it to light switch. So this is all light switch. Perfect. Let's have a look if we have anything else. Okay, we have sync TP-Link Cloud, vsync TP-Link Cloud. Yep, in this case, something useful when you train it initially, you can go to settings, and then you can do flash logs for the last 24 hours. So this is what I'm going to do. So as soon as I do that, again, I clear all the previous logs. I'm going to dashboard, I'm going to query log, it's currently empty, and to force my IoT devices to connect again, I'm going to restart my wireless AP. Again, this is the shortest path to do that. Again, because we need to double check. Yep, I'm going to restart AP, and I will be back when AP is back. So AP restarted. So let's look at our clients. So clients look good. So we go back to Pi-hole, and we click on query log again, and now we see much more green stuff, right? So we see some kind of local host, which for now we can ignore for our use case. It's not that important. Yeah, let's have a look at our dashboard. Okay, we have some light switch, we have some air purifier, we have light bulb, right? So in this case, so what I'm going to do is to test functionality. So this is an iteration process, so you may need to do it a few times to catch another domain, or probably you do an upgrade of the firmware and it goes to another URL. So it requires you some kind of, again, as I mentioned, low maintenance when you start, but when you will go down the road by using a wildcard, this is very efficient. So what I'm going to do, I'm going to test my devices. So I'm going to change the color of my light. Yeah, it did. So my bulb is working. So then let's check air purifier. And it is working, so I put it on the high. Okay, and final verification of my light switch. Okay, yep, it's working. And let's have a look if you have any new queries. Okay, yeah, so this is an example of the iteration process. So we have a TP-Link light switch requested access to a new domain, tplinkra.com. So I'm going to allow it as well. In the regular expression. Okay, light switch, add to whitelist. Okay, and I go back to query. Okay. And again, you're going like that, right? So let's try one more time. Light switch, can we do that? No, I guess it's still not working. Yeah, so now you can see it was able to resolve and it was able to go there. Yeah, so now we have functionality working. Okay, so this is how it is simple to do. Let's look at our domain, so how it is configured. This is how it looked like. And these are 3 different vendors, 3 different IoT appliances, right? So again, yep, congratulations, we have 3 gold stars. So we finalized our game. So as a final step, we'll just go over the configuration for your reference. So you see configuration of the Pi-hole. Let's look at the wireless. So we have again just two SSIDs, right? And if we scroll down here, we use multiple passphrases, and we use this configuration for isolation and filtering, right? And now I'm going to show you final SRX configuration, and we'll be done. We are back to SRX, and this is what we are going to do. I'm going to show you, slowly scrolling down, I will show you full configuration, so you can do screenshots, or you can just pause if you'd like. And that's it. And there is just one more thing I wanted to show you, so just have a look. So I'm showing you security sessions coming from the IoT devices. And just have a look. TCP 1883, TCP 1883, TCP 8883, TCP 443, TCP 1883, TCP. Just imagine how hard it would be to create IP filters or security sessions, security policies for it. It does not use standard protocols, it doesn't use standard ports. It's not all SSL like in ideal world, it's much more complicated. That's why our DNS filtering is much more suitable for this solution. Yep, this concludes the lab exercise. We finished our lab demonstration. I hope it was not too long, and I hope you learned something new and useful which you can implement in your network. I wish you all the best, and I'll see you in the next videos, including the third one, which will be bonus content. Just don't skip it. See you there.